Atamel, Google'un Londra ofisinde Developer Advocate olarak çalışmaktayım. Teknik sunumlarımı genelde İngilizce yapıyorum. O yüzden sorun olmazsa burada da İngilizceye dönmek istiyorum. Çünkü Türkçe'de zorlanıyorum biraz. Sorun olur mu yoksa? Tamam mı? Ama sorunuz olursa Türkçe sorun cevaplamaya çalışırım. Ama teknik terimleri Türkçe bilmediğim için biraz zorlanıyorum. O yüzden İngilizce yapacağım konuşmayı. Ama dediğim gibi sorunuz olursa lütfen Türkçe sorabilirsiniz. So now I switch to English. So today I want to talk about beyond the prompt. So what I mean is that I want to talk about how do you evaluate LLM applications, how do you test them, how do you secure them. So basically anything beyond the prompt. That's why I call this presentation Beyond the Prompt. So how do you productionize LLM applications? At least what I learned. So I want to pass that to you, and hopefully it will be useful to you. The presentation, at least the previous version, is already on speaker deck. So if you want to take a picture, just take this, and then you can get the PDF, and I'll share this link at the end of the presentation as well. All right. So it's very easy to get LLMs generate content, right? It's literally one API call. And with that, you get text, you can get audio and even video nowadays. So it's very easy to get started. But it's very difficult to make sure that what you get back is actually good. And I put good in quotations because you get to define what good means, right? And LLMs are especially challenging because they are not deterministic. So even if you call the LLM with the same inputs, you will get different outputs. So it's very crucial to define what you mean by good, and then you need to actually measure that good in some way. So what does it mean for an LLM output to be good? Well, maybe you mean it's structured. Let's say you are expecting a certain format or your output in certain JSON format, for example, and if it fits to that format, then you consider that output to be good, maybe. Or maybe you want the output to be correct, right? In some applications, it's very crucial that what you get back is actually factual. You don't want hallucinations or things like that. So maybe correct answers are good. Maybe you want relevant answers. For example, if I ask, how is the weather in Istanbul, and I get an answer for London, then it can be correct, but it's not relevant, right? So we want to make sure that the LLM answers us not just correct answers, but also relevant answers to the question. Or maybe you want LLM to be grounded in your data. So usually people have their own private data, and then maybe your PDFs, for example, and then you want LLM to answer just from that PDF. That's actually quite challenging. Sometimes LLM answers from the PDF, and sometimes it answers from its own knowledge. So you need to make sure that the output is actually grounded in your own data. Or maybe you want LLM to be non-toxic. You don't want it to say things it's not supposed to say. And LLMs, they use tools. They can call functions, APIs. So maybe you want to make sure that the output actually includes these tools. It calls these tools and gets the result and actually gives you information from that. So what is good is actually up to you to define, and you need to define, and maybe it's a combination of all of these things, but you need to define this upfront. And talking about structured, so when large language models first came a couple of years ago, it was actually quite a mess. Like you would get, the output was basically pretty much any kind of text. Sometimes it was plain text, sometimes it was markdown kind of text, sometimes it was JSON, and there were even cases where, sometimes it was a JSON, but there would be small mistakes in the JSON, and then you couldn't parse it properly. So it was a mess. But nowadays it got much better, and in most LLMs, actually getting structured output is quite easy. In Python, for example, there's a library called Pydantic, and it's basically classes in Python, because Python didn't really care about classes up until recently. But in Java, we had classes for a long time. But in Pydantic, you can define your class. So let's say you define a recipe class with your name and description and ingredients. So these are strings, and this is a list of strings. And then when you generate content, you call your model with your prompt, but you also call with a configuration. And in this configuration, you say, I want JSON, but I also want in this schema, and the schema is a class, right? So with that, LLM knows that it needs to reply with JSON, and also it needs to reply with this schema. And what you get back is basically this kind of JSON, where you can rely on the schema, and then you can parse that properly. And this works really well nowadays, so the structured outputs is not a problem anymore for 99.99% of the time. Of course, LLMs, you can never trust them, so in certain cases, maybe you will get something that's misformed, but for the most part, it's okay. But then how do you know the rest of the output is good? Well, you need to measure, and then the question becomes, what do you measure and how do you measure, okay? And that's what this talk is about, basically. Like, we'll look at some things that I learned on what to measure, and then some frameworks that I learned myself, and we'll take a look. Now, when you talk about measuring the LLM outputs, at some point you're gonna need some evaluation framework. These are called LLM evaluation frameworks, and there's a lot of them out there. For example, if you're on Google Cloud has something called Vertex AI, which is the AI platform of Google Cloud. And then on Vertex AI, there's something called Gen AI Eval Service that you can use to evaluate your LLM outputs. So if you're running on Google Cloud, this is the place to start. But of course, there's other solutions. There's DeepEval. It's an open source project that works not only with Google models, but it can also work with other models like OpenAI and any kind of model, really. Then after that, there's something called RAGAS. It's another open source framework. It's more for RAG, retrieval augmented generation applications, and it provides metrics for that. There's another one called Promptfoo. This is not only an evaluation framework, but it's also a security framework that we'll look at later. So if you want to do both evaluations and security, maybe Promptfoo is a better choice. There's another one called TrueLens, and there's more, okay? So these are the ones that I looked at, but there's a lot of choice out there, and I think the challenge becomes like, which one should you use? And there's no right answer, by the way, and you probably need to use a combination of them, but we'll take a look. So when you look at these models, then at some point you need to decide, okay, these frameworks, they have metrics, so what kind of metrics I can look at? So if you look at DeepEval, they have like a metrics page where they tell you some metrics, like GEval, it's based on a paper. Then there's things like faithfulness, contextual precision, contextual recall, bias, so on and so forth. Then when you look at Promptfoo, you can see that there's some similar metrics like GEval and answer relevance, stuff like that. But then there's other things like, you know, LLM rubric or some other metrics that's not listed here. Then when you look at RAGAS, it's mostly about retrieval augmented generation, so their metrics are more for that. But then you also see things like agent or tool use cases, so agent and tool metrics. So at this point, you'll be confused because you see similar metrics, but you also see different metrics, and then you're like, okay, which one should I use? I don't have a good answer for you, to be honest, because it depends on what you want to measure. So it's almost like a chicken and egg problem. So you either choose the framework and then see what you can measure with that framework, or if you know what you want to measure, then you pick a framework using that. Or maybe you do both. So maybe you use RAGAS for RAG, because it has more detailed metrics, but then maybe for simple things you can use DeepEval. So you have to kind of decide on your own like which one you need. But in terms of metrics, I think it's good to understand the landscape of metrics. And there's this really good blog post from DeepEval people, and you can get the link from here, where they talk about different classes of metrics. And I think they fall into two different categories. The first one is what's called statistical or deterministic metrics. And these are metrics that you can basically measure, and they're deterministic, meaning once you measure them, you will always get the same number. And some of them are like Blue, Rouge, Meteor, and we'll talk a little bit about them. So you can go with those. But then there's also model-based metrics. And these are metrics where you use one model to measure another model, okay? So that's what model-based scores are. And then there's some in the middle where they based on some statistics, but they also use models. I haven't looked into those kind of metrics too much, so I mainly looked at these ones and the model ones. But just know that there's basically a big landscape here, and we'll take a look at the differences between the two and why you would want to use one versus the other. But this is a good blog post to read and to understand the landscape. Now, in terms of deterministic or computational or statistical metrics, however you want to call it, these are metrics where you can basically do like things like equals. Let's say you know that the output should include some text. You can do a simple string matching for that, right? So, and for that, you don't even need an evaluation framework. You can still do simple string matching, or you can look for certain text like contains, or you can do like contains and, or starts with, so on and so forth, right? So these are the things that we already know how to do, and yeah, I mean, the frameworks, they support these metrics, but you don't even need a framework for these. Then there are other metrics like BLUE, which is mostly used for, you know, how closely your text matches a reference, right? So let's say you have some reference text that you want to use as reference. That's like the perfect output that you're expecting, and you want to see how the actual output matches to that. So you can use BLUE to get that score. There's another one called Rouge. This is more about summarization. So let's say you have a text and you want to summarize it, and then you have a reference summary, like a perfect summary that you're expecting. Then you can use Rouge to calculate what the actual summary is and how it compares to the reference, right? So that's for that, and there's others. I won't go through in all of them. But the problem is with these computational metrics is that, number one, you need a reference data set. So you need to have the perfect output to compare against. You might have that, and if you do, then great. But if you don't have that, then you can't use these metrics, right? So that's problem number one. And the second problem is that these metrics, they really fail to capture the semantic nuances of languages. I mean, languages are really complicated, and we have lots of things we naturally understand, but these scores, they don't really capture that, right? And that's the problem with the computational metrics. And that's why we will look into model-based metrics. And actually, I'll show you an example of this. So all of the examples I show, by the way, it's in this GitHub repo that I have, and I have the links in the presentation. So if you want to get to them, just get to the links and you'll see them. But let's just look at one computational metric and see how that works. And in this case, I'm using the Gen AI evaluation service from Google Cloud, but you can use DeepEval or others as well. And then in Vertex AI's Gen AI evaluation service, these are the metrics that are supported out of the box. Exact match, so if you want to match the string, then there's an exact match. There's the BLUE score, there's the Rouge score, and the Rouge has different flavors that matches multiple words, so you can use those as well. So these are the ones that are supported out of the blue, and the way you would write these is that you would basically, in a Python, you would create your class, and then you have your responses. Let's say you have these responses from the model. So I have 3 responses. So what you would typically do is that you would run some tests against your model or your endpoint, get some responses back, and then save them somewhere, and then you will load them to do this evaluation. But here I'm just putting them here. So I have these responses from the LLM, and these are my references that I expect. These are the perfect outputs that I expect. So as you see, this is hello, how are you? And this is the same, so it matches. Now here I am saying I'm good, but here we spell it out. So it's same but slightly different. And then here, the cat lay on the mat and the cat sat on the mat. It's pretty much the same. Like as humans would say this is the same, but in terms of the actual text, it's quite different because instead of sat, we say lay, right? So if you have these, then you create a data set with your response and reference, and then you create your metrics. And here I'm doing all the metrics. So I'm doing exact match, the BLUE score, and the Rouge score, right? And then I do an evaluation task and pass my metrics and my data set, and then I just run it, okay? And then this will go to the cloud, do the evaluation, and then give me the results back. You can save it in Google Cloud Storage if you like, but here I'm just printing it out. So let's say we have that, and I think I can run this and show you. And it's pretty quick usually. Within like 10 seconds we should get an answer. So let's see what we get. And I don't know if you can see this. I'll try to make this a little bit bigger. Yeah, so So as you see, like for example, here we have the response and the reference, they match 100%, and the exact match tells us it's 1, meaning 100% it matched. And the blue score is 1, the rouge score is 1, because it's like perfect match, right? But then if you look at the second one, I am good and I am good, exact match is 0, because it hasn't matched perfectly. So that's not that useful to us, right? But then if you look at the blue score, it's 0.18, so 18%. It tells us it's 18% match. Again, I mean, in our minds, like these are the same thing, but the blue score doesn't capture that. But the rouge score is 66%, so it's better, slightly better, but it doesn't capture the fact that they're almost the same. And then when we look at the cat lay on the mat and the cat sat on the mat, again, it's the same kind of thing, but then blue score says it's 48% match, where the rouge says 83% match, right? So that's why these scores are kind of useful to understand, but they don't really help that much. And that's why we need model-based metrics to kind of do this kind of comparisons, okay? And that's that. Now, if you look at model-graded metrics, then there's a lot of different metrics, like similarity match. DeepEval, it's a paper that talks about how a large language model can be a good judge for other models, and it explains why it's as good as like humans. Then there are metrics on hallucination, bias, toxicity, summarization, so on and so forth. So you need to kind of decide on what's important for your application and see if you can run those metrics. But the problem here is that you are relying on one large language model to grade another one, you know? So it's something non-deterministic, grading something non-deterministic. Is that good? I mean, according to this paper of DeepEval, it's as good as humans, because even humans don't agree on what's a good output. And then, according to the paper, actually the models are as good and sometimes better than humans. So it depends on what you want to believe. And I can show you a couple of examples. This time I'll show you Promptfoo and DeepEval and how you can do model-graded metrics with that. So in Promptfoo, you define things in YAML, which I don't really like, but that's how it is. And then you define your prompt, and then you define your provider. So these are the models that you're gonna test against. And then these are the models that you will use for similarity search. So you pick your models. My models are a bit outdated here. And then you define your tests. And in the first test, for example, I'm asking what's the capital of Cyprus, and then the assertion is type contains, and then the value is Nicosia, right? So here I'm just doing string matching. So this is a deterministic metric. It's not using models yet. But you can do this kind of deterministic metrics in Promptfoo as well. Now, if you want, this will be useful, but as I showed you before, these deterministic metrics are not great as soon as you change something in the output. So that's why you probably want a model-assisted metric. And in here, in Promptfoo, there is a metric called similarity. And it basically does a similarity search, right? So here the question is, what's the weather like in London generally? And then the value that we expect is mild and rainy. But then we are doing a similarity search, and then we are setting a threshold. So we are basically saying, if it's 70% similar to this value, then accept it as correct, right? And it will do a similarity search using the model that we provided, and then it will give us a score. So let's run this and see what we get. And then the way you run it is that Promptfoo eval, and you just point to your YAML file. And again, it will take a couple of seconds to run. And then you see I have 2 successes and 2 failures. So the exact match passes because it's exact match. But then similarity was the weather like in London generally. It failed because we get similarity of 53%, 54%, and our threshold was 70%, right? Because the output, for example, was London generally has a temperature. You see that this is the output from the LLM, and this is the output from the other LLM, and it's kind of similar, but not that similar to what we wanted. But you can play with this, and you can basically change the value and change the scores and see how it works for your use case. But it gives you more flexibility on kind of, doing more meaningful matches with that kind of metric. So that's Promptfoo. Then the next one I want to show is the DeepEval. Let's see, where is that? Yeah, DeepEval. Yeah, in DeepEval, I like it more because you define that in code, in Python. And the way it works is that first, you define your test model. So this is the model I want to test, and this is the model I want to use to evaluate that model. So here I'm using an earlier model like 1.5 Pro, which is a bigger model, as an evaluation model, and then I use Gemini 2.0, which is a more recent model, as the test model that I'm testing, right? And then you create your evaluation model, and then you create your metric. So in this case, I'm creating a metric called answer relevancy. Answer relevancy answers the question of, given this question, how relevant is the answer? Like, is it answering the question or is it not answering the question? So here, as you see, this is a model-based metric, so that's why I'm passing the evaluation model. And I'm again passing the threshold, in this case 80%. And then with that, you can run it, and then you will get an answer. So yeah, you will get a score, and then you'll see how it works. So that's answer relevancy. Another one is summarization. So in summarization, basically, let me show you this in code. So here, for example, this is the answer relevancy. So you create your LLM client, then you ask a question, why is sky blue? Then you get a response from the LLM, you get an answer. Then you create a test case, and then the test case has the input and the actual output. And then you create your evaluation model, and then you create your metric with that. And then finally, you just assert. So you assert what you get with the metric, with the test case, and that gives you a score. So that's how you write it. It's kind of like writing unit tests, but for LLMs. And we can actually run this. So let's go here, and then if I run this, and again, like it's the same kind of thing, but instead we're using DeepEval command line to run this. And by the way, DeepEval has at least 20 or so metrics, so depending on what you want to test, you will choose the metric you want. In this case, we care about the answer relevancy, so that's what we are running. And then you get something like this, where the score in this case is 1, meaning the answer was 100% relevant, and then it also gives you a reason why it thinks that, and that's it. So I'm happy with that because it's 100%. Now, if you look at something else, like summarization, for example, let's say we have this text that we want to summarize with model, but we want to make sure that it's a good summary, right? So for that, you can use summarization metric. And again, it's similar kind of thing. So you create a client, then we say, please summarize this text. Then we call the model, we get the response. Then we create a test case with the input and the output. Then we create an evaluation model. Then we create a summarization metric with that model. And then in summarization metric, there's the assessment questions. So we want to make sure that the summary answers certain questions. And those questions, you define what you want to be in the summary. So here I'm defining that the summary should have these questions answered. And then you can either call the metrics measure to get a score, or you can also do assert test, and this will run the test and give us a score, right? And with this, sorry, I need to make this bigger. So if I go and DeepEval, this was test summarization. So you'll see similar kind of thing. So it will run, it will do the assessments, and it will give us a score, and let's see what we get. All right, so in this case, again, we get 100. I mean, usually you don't get these perfect scores, but today the demo's like my guess. But it's 100%, and then it tells you why it got that. So I guess it answered all the questions that we wanted to answer. But sometimes you would see like 0.8, 0.7. And by the way, these metrics, again, since you're using large language models, they are not always the same score. Sometimes you get 0.8, sometimes you get 0.7 for the same thing. So don't look at the numbers that closely. Like, don't say, oh, is this number that? It's not going to work because you're dealing with something non-deterministic. Just look at the numbers like increasing or decreasing. If it's overall increasing, that means you're making your system better. But then don't get hung up on just the individual numbers. So that's how you can do this kind of stuff in DeepEval. Then when it comes to model gradient metrics, another area that you need to measure is what's called RAG. RAG means retrieval augmented generation. And if you were in the previous talk, they talked about I think using vector databases and doing RAG a little bit. But basically the idea of RAG is that you save your text into a vector database, and then when a user asks a question, you retrieve similar text, and then you use that as prompt to your model, and then you can answer the user with more relevant information, right? That's the idea of RAG. But then that process is, saving the documents, retrieving the relevant information, and answering the user. You need to measure that and see if it actually works. So for that, there's some metrics. And in RAG pipelines, there's two parts of it, the retriever and the generator. The retriever is the part that finds the relevant text, basically, given the question. And then once you have that and you pass it to the LLM, then LLM generates the actual output. So that's the generator part. So for each of them, there's different metrics that you can measure. And let's take a look at them. So the retriever metrics are the first one is context relevance. So context relevance answers the question of how relevant is the context for the input. So is the context that I retrieved, the text that I retrieved, relevant for the question, okay? The context recall means did it fetch all the relevant information? Because you want to make sure that your retriever fetches all the relevant information. Precision answers the question of do relevant nodes in the context rank higher than the irrelevant ones? Because ideally you pick the right things and they are ordered in the right order, so that if you pick the top 10, top 5, they are the best ones, right? So these are the retriever metrics. Then the generator metrics are answer relevance. So when we generate the output, is it actually relevant to the question? And another one is what's called faithfulness or groundedness, which means does the output factually align with the context? So is the LLM actually using the context to answer the question, or is it just not ignoring the context? So these are the general metrics, and as you see, these recall and precision, they require an expected output, meaning you need to have reference data to calculate them. And that's why it becomes a problem, because sometimes you don't have this expected output. Because of that, there's a simplified version of RAG metrics called RAG triad. So instead of measuring all of these, you just measure this one and these two, and then it becomes like this, right? So the user asks a question, and then from there you get a context, and then from the context you generate a response, right? And then each of these pieces you can measure separately. So here, context relevance measures whether the query, the context is relevant to the query. Then the groundedness measures whether the response actually aligns with the context. And then the answer relevance answers the question of, is the response even answering the question, right? So with these three metrics, you get a pretty good understanding of, if your RAG pipeline actually works. And all of this is possible to implement either in Vertex AI or DeepEval. And actually in DeepEval, I won't run this. I just want to show you, for example, this is RAG triad in DeepEval. But basically you create a test case, and then all these metrics are already there. So you create your three metrics, and then you just run your test case, and then you will get some scores, and then you can measure all of them. And I have examples of this, so if you want to try it out, you can after the talk. All right. So that's kind of the general metrics, and then the RAG metrics, and then more recently, we started having tools and agents, right? Tools is basically the LLMs calling functions, some APIs, and then agents are basically glorified tools. So it's agent, model, and tools combined together, and then with reasoning. And for that, there's tool and agent metrics. So for example, for tool, you can check things like, is the call, the function call that the LLM wants to make, is it valid? Is it calling the right things? Or does the name match? Or does the key and the value match? Stuff like that, right? So these are the tool metrics that you can measure. Now for agent, so agents, they use tools, so you can see if it can measure, if it's calling a certain tool, single tool use, but it also calls tools, multiple tools, right? And you want to make sure that those tool calls are in the order that you expect, what's called trajectory, right? And for that, there are things like exact match. So let's say you have an agent calling like tool 1, tool 2, tool 3, tool 4. You want to make sure that it's called in that order, or maybe it's in any order. You don't care what the order is, but you want to make sure that they are called, and you want to measure their precision and recall and stuff like that. So there's a lot of different things you can measure here. I actually have an example again of this in tool use and agent. Let me show you one. For example, let's say this is tool use. And the way you can do it, for example, again, you get your responses. Let's see. So let's say you have this reference. Like your reference is, I want to make sure that a function called location to latitude and longitude is being called, and it's being called with this location, London. That's my function call. That's my reference that I want to make sure that it's done. And then you get responses like this, where you don't have any tool calls, or you have tool calls with, the name doesn't match, or you have tool call with where the city doesn't match, so on and so forth. And then in these metrics, they basically capture those. They catch those kind of issues. So I show you an example here where you can see, like, if you have differences with the reference, it will catch those metrics. And same thing with the agent. If you look at the agent one, how do I, there. So if you have agents, it's basically multiple tools that's been called. And then in here, in the metrics, you can basically do exact match, in-order match, so on and so forth. I'm measuring everything here. So you will see some scores are perfect and some scores are not great because I'm measuring everything. But depending on what you want to measure, this is how you can do it. I won't run it because I don't have that much time, but all the samples are there, so you can kind of play with them later if you like. All right, so that's about measuring. So how do you measure the output of the LLMs? But then what do you do with the inputs and outputs? Because what people can pass to LLMs and what you can get from LLMs, you should really like detect and block the bad ones, right? And how do you do that? And actually there's this nice top 10 security problems for LLM applications, and they update this every year. So you can go to that website and you can see the top issues that happens. And then Promptfoo actually has a blog post that tells you how do you implement these, how do you prevent these using Promptfoo. So I think it's very useful so that you not only get to learn about these issues, but you can also implement them using Promptfoo. So this is very useful. Well, at this point, you'll need another set of frameworks, security frameworks, and Promptfoo is one that I mentioned already. There's another one called LLM Guard, which kind of sits between your LLM and your model, and then it looks at your inputs and it looks at your outputs, and it kind of tries to block them, basically. And then there's another one called Guardrails AI, and then there's many more again. I haven't tried them all, I just tried these three. You need to, again, pick and choose whatever you think you need to use. I think Promptfoo and LLM Guard are good ones, and I have examples of both. Just to show you the Promptfoo and then maybe the LLM Guard. For example, in Promptfoo, what you can do is first you define your YAML, and you can do what's called the red team testing, basically security testing for your LLM. And in the red team, you define number of tests you want, in this case just one, and you define what kind of security tests you want to do through plugins. So you can, for example, do harmful categories, you can do hallucination, hijacking, politics, whatever you want to do. They have lots of plugins here. I only enabled a few of them. And then once you enable these, it generates test cases for you. And then, let me see if I can show you that. Yeah, then from Promptfoo config, you get a red team file, and these are the actual test cases that you'll run against your LLM. And if we run that, yeah, so you would say Promptfoo red team eval, and it will look at this red team YAML file, and it will run these tests. And you see I have 12 successes and 6 failures. And if you look at some of the failures, let's see. For example, in this case, it failed because the output reveals full names, email addresses, and phone numbers of people. So you don't want that usually to have personal information in the output. So Promptfoo basically kind of generates test cases like that and checks your LLM to make sure that it doesn't do that. So you can play with different scenarios and then run it against your LLM and see how it performs. Another useful one is LLM Guard. And the way that works is that it sits between your LLM and your application, and then it controls what goes in and what comes out. For example, let's say you want to not allow code as input, because usually when people write code, they like to do something sneaky, right? So if you want to ban all the code to your application, what you can do is that you can create an input scanner, and then input scanner, there's a bunch of different input scanners you can apply, but in this case, we are using ban code scanner, which will ban all the code. And then in the prompt, I have a code, and then I pass that through the scanner, and then what I would get is that, I would get this basically, it would say the input is not valid because it has code. If you want to ban certain topics, for example, let's say we don't want to talk about politics because nobody likes politics nowadays. Here I have a prompt that says Keir Starmer is the Prime Minister of the UK, but then I have a input scanner that says ban topic politics, and then it will basically use a local model to determine that it's a topic on politics, and then it will ban it, so on and so forth. So you can do stuff like that, but then there's output scanners, the same thing, but on the way from the LLM. So let's say the LLM is supposed to only answer in French. Here I create an output scanner with the valid language of French, and then when the output is in English, then we'll get basically this is not a valid output, so that we don't display English to users. Instead we'll display French. And one of the useful ones is the anonymize and de-anonymize scanner. So let's say you have this prompt where you are saying to the LLM, make a SQL insert statement with this user, name is this, email is that, with this IP address. So there's a lot of personal information here. You don't want to send that to the LLM because you don't know where that information is going to end up, right? But what you can do is that you can pass this through an anonymized input scanner. And once you pass it through that, you will get this sanitized prompt. And in the sanitized prompt, you will see that the email and the phone number is redacted. So they will mask it, basically. Then you call your model with this mask input. So your model doesn't see the personal information. Then as a response, you get this text in redacted email addresses. And then you pass that through an output scanner and de-anonymize it. That way you get the information back, and then you can use it in your own application. That way you can deal with personal information, but without having to send it and receive it back. So that's the kind of things that you can do with LLM Guard. And again, the samples are out there. Feel free to check it out. Okay, I think I'm almost out of time, right? Yeah, that's it. Perfect timing. Yeah, so hopefully this was useful to you. And as I said, the deck is here. And we have a couple of minutes, so feel free to ask me any questions in English or Turkish. Thank you. I also have stickers, so I'll just leave them here if you want to get some Google Cloud and Google Developers stickers, okay? All right.
Is there questions?
Hello.
Hey.
I have a question about model evaluation. So I would like to know if there's a workaround for setting the metric threshold dynamically based on the quote-unquote quality of the prompt. Because I don't think we can expect the same stability and relevancy between models if our prompt is basically gibberish. So this might mislead us into thinking that our model is faulty while the prompt is faulty. So
Right.
if there's a workaround for setting the threshold dynamically, I would appreciate that.
Yeah, unfortunately, no. Yeah, and that's the biggest problem with these testing methods is that you rely on a model and that's why they have a threshold, because, you know, how do you know it failed or not? But then the question becomes, how do you set, what number should you set? And there's no right answer. I mean, you really need to test it with the certain model version and with the certain prompt, and then kind of figure out what's acceptable to you, and then set that number according to that. So you still need to do a lot of work to kind of figure that out yourself.
I see, thank you.
Yeah. Any other questions?
Başka soru var mı acaba?
So, although Llama 3 version is the best version of the Llama, Llama 4 is the biggest disappointment for the users. And in your point of the view, what was the biggest mistake of Meta?
What was the biggest mistake of Meta?
Yeah, about Llama 4.
I don't know. I don't work for Meta, so I'm not sure, to be honest. I haven't used Llama myself. I use Gemma, which is the open version from Google, but I haven't played with Llama to have an opinion.
Thank you very much.
Yeah.
Hello, thank you for great presentation. And my question is, you talked mostly about text-based results. So
Right.
do you know if there is any image-based or other outputs-based evaluation?
That's a good question. I know I've seen on DeepEval like multimodal evaluations, but I haven't played with them too much. And I don't know what you would exactly test, like let's say with an image-based thing. So I know some things are there, but I just haven't played with them too much, so I don't know.
Thank you very much.
Yeah.
Başka soru var mı acaba?
You're good?
Okay.
Yeah, okay, thanks very much.
Teşekkürler.
If you want some stickers, please come and get them. Thank you.